Okay, so we're going to look at inequalities, and the first thing that you have to know with inequalities is that all the rules of maths still stay the same. And if you think about this with just a kind of a smidge of logic, then it all kind of fits in together and makes sense. So the first thing we're going to do is represent inequalities on a number line, because this is a really important skill that you have to be able to do. So if we know that, and we should also talk about, what are our inequalities first. Our inequalities are greater than, less than, greater than or equal to, and less than or equal to. So if we're looking here, it says x is greater than or equal to 6. So if we're writing this out on a number line, just please excuse me, I don't have a huge amount of room, so I'm just going to write, here's going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, if we're talking about greater than 6, that's anything from 6 and above. So if I now draw my inequality, I'm including 6, so I used a closed-in circle, and I'm pointing towards the bigger positive numbers because I'm talking about things that are greater than 6. Now, next one, x is less than -3. So now I'm going to do the opposite. I'm going to be writing my numbers in this direction. I'm going to start off at 0, -1, -2, -3, -4, -5, -6. Okay, so now x is less than -3. Now this is not a less than or equal to, so we use an open circle to show that it's not equal to -3, and we point the arrow in this direction where our numbers are getting smaller or more negative. All right, next one, we've got x is between greater than 2 but less than 10 or equal to 10. So here, and I'm just going to make this go up in 2s to make it a bit easier. 4, 6, 8, 10. Just make it a little bit bigger to see where we're going. Now we're talking about greater than 2. So 2 is our smallest value, and we use an open circle. And less than or equal to 10. So we're going to use a closed-in circle for 10. Join this up, and that means x is between those two values. Okay, so anything within there, that's what x could be. Now, when it comes to solving, again, all of our regular algebraic rules that we use and we know we're really familiar with, they all stay exactly the same except for one little thing that we add in, which I'll talk about in the second example. So this one here, we've got 2x plus 16 is less than or equal to 8. So we're going to solve like normal. If we know we're adding 16 to 2x, we minus that 16. So we're left with 2x. Now 8 minus 16 is -8. All right, and then we're multiplying that x by 2, so we divide by 2 on both sides, and we're left with x is less than or equal to -4. Okay, so if we were then going to draw that out, we would have, say that's 0, -2, -4, -6, -8. Okay, we would be going everything less than -4. There's our solution. Okay, next one. We've got 7x, -7x, plus 10 is greater than or equal to -39. So again, the first thing we're going to do is minus that 10, because that's what we're adding on to the -7x. So -7x is greater than or equal to -49. Okay, then the next thing we're going to do is we're going to divide that through by 7 on both sides. So we're going to divide both sides by 7. That cancels out, so we're left with -x is greater than or equal to -49 divided by 7, that's -7. Now, I'm going to represent to you on a number line. We're not finished this yet because we've still got that negative in front of the x, but I'm going to show you what this looks like. So if we know that -x is bigger than -7, that means that the numbers that x must be, if this is bigger than that, then negative whatever x is has to be bigger than -7. So what kind of numbers are bigger than -7? Well, I know numbers that are bigger than -7 are -6, -5, -4, etc., etc. Getting bigger, getting more positive, okay, or getting closer to 0, those numbers are bigger or bigger than -7. So what kind of a value could x be? Now, if I know I've got -x, what could x be to make -6? Well, if x was +6, okay, then I'd have -6, which gives me -6. To make -5, if I've got -x, I'd have +5, which would give me -5. Okay, so really the solutions that we're looking for here are positive values, whereby once you make them negative, they're going to be bigger than -7. So I'm just going to draw it over here because I'm running out of room. Okay, but I should be able to see here, anything from 7, 6, 5, 4, anything that is less than or equal to +7 are going to give me values that are going to be greater than or equal to -7. So hopefully that kind of makes sense. If it doesn't, then the main take-home thing that you need to remember whenever you're doing a solving like this and you end up with a -x, you get rid of that negative by multiplying both sides by -1. So you multiply both sides by -1, so you end up with x and 7, and then you change the direction of that inequality sign. So you end up with x, instead of being greater than or equal to 7, that becomes x is less than or equal to 7, which is the same thing as what we did on our number line here. Okay, now if you want to, you could sub in a number that's less than 7 and you could check to see whether your inequality is right. You do not have to do this every time, but you can if you want. So again, I'm just going to go up a little bit. So up here, if I wanted to check, I could say pick x is equal to, or a number that's less than 7, let's go with 3. Okay, so we'll go, that's less than 7, so we'll go with 3. And now I could plug this in and I could say -7 times 3, so I'm just using that original equation here, plus 10, and I want that to be bigger than or equal to -39. Okay, so -7 times 3 is -21, okay, plus 10. Now that, if I add on 10 to -21, that gives me -11. Now -11 is bigger than -39 because it's closer to 0. So that's perfect. Alrighty, last little one. Now this one isn't technically, I think, part of the second form curriculum, but I think it's a really good thing to think about because we have talked about solving equations with quadratics, and so this just kind of brings it in with inequalities. So hopefully you remember that there's a really special thing I said about solving equations with quadratics, and that is, so being quadratic, that means that you've got a squared, a power of 2. That is that we know that 5 squared is equal to 25. We also know that -5, okay, so -5 times -5, -5 squared is also equal to +25. So whenever you're solving an equation with squared, when we take the square root of both sides, okay, we always have plus or minus whatever that answer is, because the answer could be +5 or it could be also -5. So we end up with x plus or minus 5. Now, how this works with an inequality, in this case, we're looking for where x squared is bigger than 25. So we know for the positive version of this, okay, that here's 5, here's 0, here's -5, okay. We know that any value bigger than 5 squared is going to give us an answer that's bigger than 25. Okay, so for example, 6 squared is 36, so that's bigger than 25. So one of our answers is going to be anything that's bigger than +5. Now, -6 squared is also equal to +36. So our other answer is that this value could be less than -5, because anything bigger than that, if anything smaller than that -5, once you square it, it's going to be a really big, it's going to be a bigger positive squared value. Okay, so in this case, our inequality is that x is bigger than +5 or x is less than -5. Okay, so it could be one or either of those. X could be bigger than +5 or x could be less than -5. Now again, that's not strictly part of the curriculum, so again, if you're finding that hard, don't stress about it too much for the moment, but I think it's an interesting way of combining solving with quadratics and inequalities. All right, okay, have another go, or have a go at the other worksheet, and I won't see you on Friday because it's XYAT. Have a lovely time, and if you want anything extra to do over the long weekend, let me know. Okay, bye.